Well, good morning, class. Our topic for this video will be matrices. Well, let's start from the basics with what matrices are. Well, if you are a student of computer sciences or computer studies, your definite answer would definitely be that matrices are numbers that are put into a two-dimensional array. That's what you have been taught all your lives. But that's just a partial definition. The complete definition of a matrix is that it's a collection of numbers that are arranged into a fixed numbers of rows and columns, and usually these numbers would always be real numbers in your case, but in general they also can be complex numbers, but you won't be seeing them over here. They're none of your business at the moment. First of all, let's write the heading for the day: matrices. Okay, so first of all, let's show you how to denote a matrix. We write down the order of a matrix, which is order m into n, where m is the number of rows and n is the columns. Okay, so if we have a matrix for suppose 1, 2, 3, 4, 5, 6, let's close it down. What is the order of this matrix? How many rows does it have? It has 2 rows. Rows are horizontal, 1 and 2, row 1, row 2. These are the 3 columns. So it has 3 columns and 2 rows. So what would be the order of this matrix? Basically it would be rows, which are 2 multiplied by 3. This is the order of this matrix. Okay, so each element, or you can say numbers with what you see over here, each number that is present in a matrix is the element of a matrix. Okay, so how many elements do this particular matrix has? It has 1, 2, 3, 4, 5, 6. So you can also calculate it by actually multiplying the number of rows and columns. You'll get the number of elements present in the matrix, and each element has a specific entry, a specific position inside the particular matrix, like the number 5 over here. The number 5 is present in the second row and in the second column. Okay, like we see the number 3, it's present in the first row, third column. Okay, so you can figure out which entry or which number, which element is basically present in what position in a particular matrix. So that's just the basics of what matrices are. Okay, so we will now be moving on towards addition of matrices. Well, addition of matrices is fairly very simple for you guys, I think, on this level. 2 matrices can be added and subtracted likewise in a similar fashion, but addition and subtraction will only take place entry wise. So basically the order of both the matrices that are going to be added or that are going to be subtracted should be the same. If the order of the matrices are not same, then they would definitely not be added or subtracted. Let's see an example. Okay, so this is a matrix 1, 2, 3, 4, and if we add it to a matrix which is 0, 1, 1, 0. Okay, so what is basically actually happening inside the addition? The first row, first column in the first matrix will be added to the first row, first column in the second matrix. So we'll write 1 plus 0. Okay, likewise each entry would be added to the corresponding entry in the second matrix. Like 3 would be added to 1, 3 plus 1. 2 would be added to 1, 2 plus 1. 4 would be added to 0, 4 plus 0. Okay, what's the result? 1 plus 0 is 1, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 0 is 4. So this is the resultant matrix. Okay, and remember this thing, that the resultant matrix which will be formed after the addition or subtraction will always be of the same order. It would have the same number of rows and same number of columns. Okay, let's see another example. This was fairly easy. Let's see when actually you cannot add or subtract two matrices. Let's see, let's take an example. 1 2 4 6 9 8. Okay, and we are going to add this to 1 5 3 6 7 5. Let's take elements over here, 4 3 and 2. Okay, so the order of this matrix is number of rows are 3, number of columns are 2. 3 into 2. The order of this matrix is, it's a 3 by 3 matrix, 9 elements, you can see it, 3 by 3. So the order of both of these matrices is not equal, so they cannot be added. You can also check it. You will add 1 to 1, first row first column, in both the matrices, 2 with 5, but you do not have anything in this matrix over here, the third element, that you should be adding to this 4 over here. That is the only reason why you cannot add matrices that are of different orders, basically. Okay, likewise we should also see an example for subtraction. Subtraction is basically just exactly the same as addition. 1 0 1 1, and when we minus it with 4 6 1 by 2 and 3. Okay, what do we get? We have to work out entry wise. Okay, so the first column first row will be minus with the first column first row in the second matrix. 1 minus 4, 1 minus 1 by half, 1 minus 1 by 2, sorry, mind you, 0 minus 6. First row second column, first row second column, both would be subtracted entry wise, order wise. Okay, likewise 1 minus 3. What does the resultant that we get? 1 minus 4 is minus 3, 1 minus half is a half, 0 minus 6 is minus 6, 1 minus 3 is minus 2. See, even in subtraction the order of the matrix does not change. It was a 2 by 2 matrix that was being subtracted by a 2 by 2 matrix, and the resultant is also a 2 by 2 matrix. Okay, in the next video now we'll be talking about multiplying two matrices, and that is going to be very easy for you as well. Okay, thank you, stay tuned.